Good evening, everyone. This is lecture number 7. And in this class, we are going to wind up Prism once and for all. In the previous class, if you remember, we had solved some problems on Prism, some really good problems there. What I have seen, I was going through the last year papers, and many a time they have asked question based on the angle of incidence being 0 degree, or the angle of emergence being 0 degree or 90 degree. They've asked questions like that repeatedly. So I worked out some important cases for you. So what I would like to do is I would make you understand those cases, and without going into much detail, you will just note down those cases. Do we understand them? Do we understand what I'm saying?
Yes, sir.
I've seen, apart from the questions that we have done, those questions were very general, in which the angle of incidence was not 0 or 90. It was somewhere in between. We had done those questions, but what I have seen for the past some years, they are giving some very specific questions, and therefore I have found out those cases of which those questions are coming from, and we will now note down those cases with diagrams. Okay, so here comes, let me put this case number 1, and case number 1 is normal incidence. So you will write the heading case number 1, different cases, some special cases. Case number 1, normal incidence. Now please understand, when I say normal incidence, we have seen the law of reversibility of light ray. Do we understand this? Now, if the ray is incident normally, it will emerge out from the prism in some particular direction. If I make that particular direction as the incident ray, the same ray will emerge out normally. Do we understand this? So if I say normal incidence and I reverse the case, it becomes the case of normal emergence. Do we understand this? Everyone, do we understand what I'm saying? If I do a case of normal incidence, the ray is incident normally and it is coming out from the other side. If I reverse that ray, it becomes a case of normal emergence. Do we understand this?
Yes, sir.
Okay, so the first case is, you can call it the case of normal incidence or normal emergence, and I'll show you that case, and you will just note down what is going to happen in that case, and we will keep it like this with us. Small things that you must remember. If you can remember those, what can happen is, when that question comes, you would be able to, what has happened, something wrong is, sometimes this machine fails us. Normal incidence and normal emergence. So look at these three cases. These three cases are simple cases of normal incidence or normal emergence. In case number 1, what do we see? The ray is incident normally. When I say it is incident normally, the angle of incidence becomes 0. Do we understand this? Do we understand this?
Yes, sir.
Okay, now angle of incidence is 0, and then I have the ray incident normally. It will, so the angle of incidence is 0. The angle of emergence will also, the angle of refraction will also be 0, but then it will fall at a different angle on the second phase, and so on onto the third phase. Do we understand this?
Yes, sir.
In case number 2, what we have done is, sort of reverse the case number 1. If I reverse the case number 1, it becomes case number 2. Do we understand this?
Yes, sir.
In case number 3, what we have done, and this is a question that I have seen in JEE Advanced of 1 year. What is this hatch that I have done?
Reflecting surface.
Yes, reflecting surface. What we have done here is we have silvered one of the surfaces of the prism. We have silvered one of those surfaces, so light cannot go on the other side. It has to be reflected back, and as you can see, it is getting incident normally. That means the way it goes, the same way it will come back. Do we understand this?
Yes, sir.
Yes or no will give me more confidence. Raise of hands will give me more confidence. 3 different cases, and I've seen these 3 different cases come many times in the exam. Now, obviously, how we are going to do this? We are going to do this with simple laws, with simple formulae, Snell's law, and all those things that we have already done. Now, when we apply that law, Snell's law, and all those things that we have done, we can get some very simple formula for this. For example, I can write mu as sine I by sine of A. If I is 0, then instead of I, you will write E. And this will be the formula for all the 3 cases. Because case number 1 is the reverse of case number 2. Case number 3 is sort of case number 1 and 2 mixed together as well. So you can use this formula. Here you can see very easily that one of the angle of refractions, either R1 or R2, is going to be 0. R1 or R2 is going to be 0. So the other angle will become equal to the angle of prism. Do we understand this? The
Yes, sir.
angle of prism is here, angle A. So if one of the angles R1 and R2 becomes 0, the prism angle becomes equal to the other angle, and sine of I or E, depending on where it is getting refracted, sine of I or sine of E divided by sine of R, the R becomes equal to A. Sine of I divided by sine of R becomes mu, and in this case your deviation becomes I minus A. If I is 0, you put, instead of I, you put the value of E. Do we understand this?
Yes, sir.
All these 3 cases, you don't have to solve anything, just put them and you move ahead and you stay happy in your life. Do you understand all the 3 diagrams, bacha? I'll give you 2 minutes. Remember, whenever I've written I, if I is 0, you just put the, instead of I, you put E. Okay? Because if I is 0, E will not be 0. If E is 0, I will not be 0. Do we understand this?
Yes, sir.
This was the case of normal incidence or angle of incidence or angle of emergence. One of them is equal to 0. I will give you 2 minutes to note this down.
Completed. Completed, sir.
Completed? Okay. That takes us to the next case, and the next case which I have seen coming in exam is grazing emergence. This case also includes the condition of TIR. total internal reflection. What do you mean by grazing? What do you mean by grazing emergence? Can anyone tell me what do you mean by grazing emergence? What do you mean by grazing emergence? Anyone? Grazing emergence. Now, grazing emergence means if I just draw this as normal here, this is normal here, this is my, let us say, incident ray, this is my reflected ray, refracted ray. I'm just drawing a general diagram. And we have an emergent ray. If the emergent ray, oops, if the emergent ray goes like this, that is known as grazing emergence. Now, can you tell me what do you mean by grazing emergence? Grazing emergence means the angle of emergence becomes, do we understand this?
Yes, sir.
Now, whenever any type of ray is incident on a prism, three things can happen. Three things can happen. What are those three things that can happen? Case number one is the case where the ray emerges like this. Then there are two more cases that are possible. The ray may emerge like this outside, or the ray may get what? May get totally internally reflected, and it can follow case number three. So there are three things that are possible. 1, 2, 3. In case number one, it is emerging out, or we can call it just emerging out, managing to emerge out. It emerges out at an angle of 90 degrees. Case number two, it can definitely emerge out. Case number three, it undergoes TIR. Now, it's not possible for us to give some general formula, but I have made one general formula for any angle of incidence, and you will know that general formula for any angle of incidence. The minimum angle of incidence, the minimum angle of incidence to get grazing emergence. So if you want grazing emergence, the minimum angle of incidence is given by this formula. If you can remember it, now this will not probably come in JEE Main. This will probably come in a JEE Advanced ka paper. It's not very difficult to derive this, but it will take some time for me, maybe 15 to 10, 15 minutes to derive this and then give you this answer. So instead of wasting that 15 minutes, it's not required. I'll just give you the final answer that we are supposed to get. To have grazing emergence, this is the formula that you must remember. Again, this formula is not going to come in JEE Mains as far as I understand, because this might be just too troublesome for JEE Mains, and it will take some time if someone does not know to derive this result. Do we understand this? So this formula is very complicated. As you can see, for a general angle, this formula is very complicated. Do you see this? Yes or no?
Yes, sir.
For a general angle, this formula is very complicated. But if we have some special cases, then you will have to remember those special cases can come, and I have seen it coming in JEE Advanced. So I am just giving you that so that if it comes again in JEE Main, you should be able to understand. Case number one is normal incidence. So I will just draw the case of normal incidence and just give you a quick snapshot of what is going to happen for normal incidence, and the formula becomes very, very simple, and you can just note it down for all the three cases. What has happened here? Funny things happen in life. I don't know why they happen at the same time. Okay, it has happened again. I think my laptop, since I have upgraded it yesterday, it is giving me trouble. Okay, this is the first case of normal incidence. Oops. Normal incidence, as you can see, the incident ray is falling normally. Do you see this? So you have to remember three cases are possible. Case number one, ray emerging out. Case number two, ray coming out at 90 degrees. And case number three, ray getting total internally reflected. We solved the same question in the last class. Yes or no, where they were asking you what is the base angle for the ray getting emerging out. This is a special case of that same thing. And what you got to remember, for ray to emerge out, angle A must be less than the critical angle, or mu must be less than cosec of A. If you just remember one condition, the other three will come automatically. The other three will come automatically if you just remember cosec of A. If you just remember cosec of A, the other three cases are automatically there. Do we understand this, bacha? So for ray
Yes,
to
sir.
emerge out, A prism angle should be less than the critical angle. In this case, because this is a special case, ray is falling normally onto it. If A becomes equal to C, then I will have grazing emergence. If A is greater than C, I will have total internal reflection. This is a very, very important case. I have seen it come in multiple times in your JEE main. And that is why I have given you this. This has come multiple times in your JEE main. One, this one, and another a very, very special one. Remember, all these things, they have not come from the heaven, from the sky. They've all been derived by the 6 or 7 small formulae that we have seen. R1 plus R2 is A plus delta, and so on. A is R1 plus R2. A plus delta is I plus E. From those simple formulae, everything has been derived. And Snell's law, mu1 into sine I1 is equal to mu2 into sine I2. Everything has been derived from there. And for total internal reflection, your incident angle, here one angle is 0, so the other angle becomes equal to A. The incident angle becomes equal to A. That should be less than critical angle. It will come out. If it is equal to critical angle, it will emerge at 90 degrees. If it is greater than critical angle, it will get total internally reflected. Do we understand this?
Yes, sir. Yes, sir.
Well done, beta. If you can remember, see, these are just special implications of that question. I and R, one I and one R are 0. The other I and other R are not 0. So that is why everything looks so simple and so elegant. Have you noted it down, bacha?
No, sir.
Please note it down, beta. I hope you are understanding it, what I'm saying.
Yes, sir. Yes, sir.
Okay. Let me know when you are done. Shall we move ahead in life?
Completed, sir.
Okay.
Completed, sir.
The first special case was when the angle of incidence was 0. The second special case is when the angle of incidence is also 90 degrees. Do we see this here? So this is known as grazing incidence, the red one, grazing incidence. And if you have this ray 2, this is grazing emergence. Grazing incidence and grazing emergence. This question has come in JEE Advanced. Grazing incidence, grazing emergence. Special case. The first formula that I told you was the most general formula. These are special cases. Do we understand this? In that, you have to remember that A should be less than C. Here, what you got to remember is, in first case, first special case, you have to remember A is less than C. In second case, what you got to remember? Tell me, is there on your board right now? It is less than 2C. And again, it has not come from heaven. Simple things have been done and the formula have been given. A is less than 2C. So mu is less than cosec of A by 2. And the rest of the story follows. If A is equal to 2C, you will have grazing emergence. If A is greater than 2C, you will have total internal reflection. Two very special cases, and you can just note them down. And if God is there with you, you might get a simple, straightforward question based on this. I'll give you 2 minutes to note it down.
Done, sir.
Okay, sir?
Pakka, sir.
Can I give you a question now, sir?
Yes, sir.
Okay, sir? Chalo, sir.
Yes.
Let's, sir, see, sir, how much you can apply it. I would be pretty happy if you can apply it.
Okay.
Oops, let me see. This was a question that came in one of the JEE. Let's see if you can do it for me. For a prism angle is 60 degrees. N I think n is the refractive index, is root over 7 by 3. Find the minimum possible angle of incidence so that the ray is refracted from the second surface. Also find delta maximum. Now remember, whenever we have the angle of emergence as 90 degrees, note it down. Whenever we have angle of emergence as 90 degrees, whenever we have angle of emergence as 90 degrees, or the angle of incidence as 90 degrees, both cannot be 90. I hope you understand that. Wherever we have any one of these angles as 90 degrees, then we have the maximum deviation. Will you remember this? Note it down. So this was the second reason of giving this question. Let's see if you can do it. Give you 2 minutes to do it.
30, sir.
Well done. 30. I think that is the answer. Minimum angle of incidence is 30. What about maximum deviation, bacha? I have not given you the formula of maximum deviation because I wanted to give you in this question so that you will remember it. I have not given you the formula for maximum deviation, but my dear friends, can you tell me what will be the formula?
Minimum incidence plus 90 degrees minus angle of prism.
Wow, well done. That is correct. That is absolutely correct. That would be the formula, and it does not take rocket science to do this. We just have to use whatever we know. I plus E minus A. E is 90, so everything comes automatically. Yes or no? No, yes.
Yes, sir.
How did you get the value of minimum incidence? Yes, everyone has done this. The class that I cannot see. Bacha, have you done this? The class that I cannot see is already gone. No, it's there.
Applied just formula, sir.
Yes, you just apply the formula, and I forget the formula. So can anyone help me with the formula? I minimum is how much? Sine inverse of, sine inverse is what I what I understand. Sine inverse of
Root over mu square minus 1
root over mu square minus 1. Okay, that looks good. Then
into sin A minus cos A.
into sine A, sine of A minus cos of A. That looks good. One sine A I remember, one cos A I remember. That looks good. You just put the values. And I think you will get here as sine inverse of half. Yes or no? That is why that mu was given as root over 7 by 3. Remember, whenever you get something like this, it is because they want to make your calculations simpler. So your I minimum becomes 30 degrees. When your I minimum becomes your 30 degrees, your deviation becomes max. Please, 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 please note it down. They might, oops, what happened here? They might ask you, when does the deviation become maximum? Any one of these should be 90 degrees. If angle of incidence is 90 degrees, then also maximum deviation. If angle of emergence is 90 degrees, then also maximum deviation. Both cannot be 90 because then it is not a prism. Then it becomes a glass slab. So delta max will be equal to I plus E. I is 30 plus E is 90 minus angle of prism. And I think you will get it as 60 degrees. Well done. Great. So do we understand the implications of this formula? Shall we move ahead in life? Oops, we have moved ahead. The page has scrolled on its own. Yes, can you move ahead in life then? Everybody
Yes, sir.
noted this down? Then we come to the heading of today's chapter, today's class, and the heading of today's class was dispersion. Now, can you tell me, my dear friends, what do you mean by dispersion? Can you tell me what do you mean by dispersion? Now, whenever light is refracted, and if we talk about white light, the light that you see in my room, the light that is there in your room, white light. Is white light does white light consist of only one color, or does it consist of other colors as well? Is white light a single color made up of a single color, or does it have other colors as well?
Spreading of light into different colors.
Yes, that is known as dispersion, and that can only happen if the light has different colors. White light consists of basically 7 colors. Yes or no?
Yes, sir.
Now these colors, whenever someone says white light, he means that more than one wavelength. These 7 colors have different wavelengths. Yes or no?
Yes, sir.
Who has the maximum wavelength and who has the
Red.
minimum wavelength?
Maximum wavelength red, sir.
Red is having maximum wavelength. So wavelength of red is greater than the smallest one is violet. Now, we have seen that the refractive index mu depends on lambda. Yes or no?
Yes, sir.
Today we are going to see the actual formula that is known as the Cauchy's formula, and this Cauchy's formula is not in your course. You just have to know that there is something known as this Cauchy's formula, and it's a very long formula, but we'll just write the first 2 terms of Cauchy's formula. And this Cauchy's formula tells us that mu of any medium depends on the wavelength of light, and it is 1 plus b by lambda square plus c by lambda to the power 4, and it is a series like this. ABC are constants for a given medium. We neglect the higher terms, we just take the first 2 terms, so we get that the lambda for any material depends on the wavelength. In fact, it is inversely proportional to lambda square. Do we understand this? That
Yes, sir.
means
Yes, sir.
that means when you increase lambda, the refractive index decreases. Yes or no? We've seen that. When we increase lambda, refractive index decreases. And that is why whenever white light gets refracted, because white light consists of different colors will be refracted, will be deviated in a different way. Do we understand this? Yes or no?
Yes, sir.
Okay, my screen has gone. Now, if I just take a very simple scenario, take the scenario of, let us say this is interface between 2 mediums, and I have white light. This is white light incident on this medium. Now, if this white light was not white light, if it is made up of only one color, it will get refracted.
Sir, go to previous slide also.
What happened?
Can you go to previous slide?
What is there in the previous slide? Beta? Only that formula is there. 1 plus a plus b by lambda square. That is what you need to remember. This formula is not in your course. Just have to remember that mu depends on lambda. It is inversely proportional to lambda. Noted it down? Can you move further ahead? Okay.
Is
you
that
move?
U or mu, sir?
It is mu beta, refractive index. I've written it as mu. Sorry. This mu beta, refractive index.
Completed, sir.
Okay.
Okay, sir.
Since refractive index depends on wavelength, who will have more refractive index, violet or red?
Red.
Refractive index is inversely proportional to lambda.
Violet, sir.
Violet. So violet light will be, and I don't have a violet color here, let me call this as violet. The violet light will be refracted most, and the red light would be refracted the least. Do we understand this?
Yes, sir.
RV. The yellow one, and I don't have a yellow. Okay, let me create a yellow. Let me use this as yellow. If I can use it. Yes, I can use. This is yellow. The yellow one is somewhere in between. Do we understand this?
Yes, sir.
This is how light normally gets refracted. If white light falls, red would be deviated minimum and violet would be deviated maximum. Do we understand this? This is the original path. This is the original path. This is the path of red light. This is the path of violet light. And my dear yellow light, this is the path of the yellow light. They are not parallel to each other. Do you understand? They are not parallel to each other. They are getting at different angles. Yes or no? We understand this?
Yes, sir.
Now, bacha, the deviation of red light is this angle. We call it delta R. Do we understand this?
Yes, sir. Yes,
Well
sir.
done. We call this as delta Y. Do we understand this? And we call this one as delta violet. Everyone got this? Deviation
Yes,
of the three. Now this deviation only happens when it is getting refracted by one surface or it is getting refracted by a prism. Now I'm going to show you what happens when it gets refracted by a slab. Have you noted this down? Have you noted this down, beta?
no, sir.
You need to increase your speed a bit. That would be better if you can increase it, so that we can just do some things quicker than we are supposed to do it. Oops, what is happening here? Not good. Okay, have you noted down, bacha? This happens when there is one surface. If I have a glass
Sir, can
slab
you
and
increase the size of the image?
yes, I've done that. Don't worry. I was just doing that. Okay. Now, you don't have to draw this. You just have to understand this. Okay. When there is a glass slab, this deviation does not happen. You just have to understand. You don't have to draw the other diagram. Do you understand this? The other diagram is of no use. When you have only one surface, then only the deviation occurs. When there is two plane surfaces, number one and number two, what happens? Whatever deviation happens from the one surface, the second surface neglects that deviation, and all these light, they will emerge parallel to each other. Do we understand this? So here,
Yes,
this
sir.
dispersion does not happen. Here, dispersion happens. This is what you need to understand. Did you get my point, bacha? This
Yes,
one
sir.
plane surface, you will have deviation. Alag wavelengths, different wavelengths would be deviated differently. This phenomena is known as dispersion. Do we understand this?
Yes, sir.
And it only happens if there is only one surface. If there are two plane surfaces, this will not happen. Everyone got this concept correct?
Yes.
But what happens when light passes through a prism? What happens when light passes through a prism? Prism also has two plane surfaces, but those plane surfaces are not parallel to each other. Yes or no?
Yes, sir.
So what do you think? I want to know your thoughts. Will dispersion happen through a prism or not?
Happens, sir.
Depends, or it will surely happen.
Happens, sir.
It will surely happen because through one surface they will get refracted, through the other surface they will also get refracted, but the two surfaces are not parallel, they are at an angle. So you will have a lot of deviation. As you can see, the deviation that you saw on the plane surface was less, but the deviation that you are seeing here is pretty more compared to that one surface. Do we understand this?
Sir.
On the extreme left, we have the white, right? Why I'm drawing yellow for white? All the colors are deviating. Which color will deviate the most?
Violet.
Yeah, so here you will have the violet color line. This is the violet color line, and this is the red color line. And then they deviate again. So this is how they emerge out. Red emerges on top, and violet emerges on the bottom. Delta R, what we had drawn was for one surface, this is for two surfaces. Delta R is the deviation for red. Remember, deviation for red is minimum. Let me write it in red. Would be better if I can write it in red. What's happening here? Something not working properly, definitely. Deviation of red is minimum. Do we see this? Deviation of violet is maximum. What do you think about yellow? Deviation of yellow is exactly, very approximately, very nearly mean of the two. Yellow light occurs exactly in between the two. Do we see this?
Yes, sir.
Therefore, the deviation of yellow light is known as mean deviation. Do we understand this, bacha?
Sir.
This is the first term that you have to understand here. The first term that you have to understand here is mean deviation, which is the deviation of our own friendly yellow light. Our own friendly yellow light. And whenever a question comes on dispersion, my dear friend, that will only come for thin prisms. Dispersion by thin prism, because that is the only thing that is there in your course. Dispersion by thin prism. Now, going back to the last class, can you tell me for thin prism, what will be the formula for delta y? Deviation of y, mean deviation.
Mu minus 1 into A.
Mu of what?
Prism.
No, mu for the yellow
Medium.
light. Do we understand this?
Yes, sir.
Because for different lights, mu is going to be different. This is the first thing that we have to understand in this. That is your mean deviation. And this mean deviation is mu y minus 1 times A. Everyone is getting this point?
Yes, sir.
Yes or no? No, yes? Now,
Yes, sir.
bacha, what happens is in problem, mu y is not given. Mu y is not given in the problem. Mu r and mu v is given to you in the problem. Sometimes they will give you mu y also, but many a times they will not give you mu y. If they don't give you the value of mu y, there is a very small way, there is a very simple way of calculating the value of mu y. Can you tell me what is that way of calculating mu y? If mu y is not given and
Mu E minus mu R.
it will be, it is a mean, bacha, average, mean. So it will be mu v plus mu r divided by 2. Can you remember this formula for me?
Okay.
If mu y is not given, my dear friends, you can use mu v plus mu r by 2 for mu y. Anyone understand this? Please raise your hand so that I understand that we are there. Online class, offline class. Shreya, are you there in the class, bacha? You understand this? Okay. Then what? Then you see a small angle theta here. Do you see this small angle theta here?
Yes, sir.
The small angle theta. The small angle theta is the angle between the red light and the violet light. Yes or no?
Yes, sir.
This small angle theta is known as angular dispersion. So these are the two terms that we have to understand. If we would have written their definition, we would not have understood it. And therefore, I have shown you this diagram so that we can understand the different terms. Theta is known as angular dispersion. Now, how will you find out this angular dispersion, my dear friends? This angular dispersion, theta, how will you find it out? It's right there in front of your eyes. Open your
Deviation
eyes.
of V minus deviation of R.
Well done. It will be deviation of me, V minus deviation of R. That is formula number 1. Let us log this formula. Formula number 1 has been logged in yellow. Now what I can do is I can put the values of mu V and mu R and find out formula number 2. Can you tell me what will be formula number 2? And then we will lock it again. Formula number 2 will be putting the value of delta V and delta R. Delta V is mu V minus 1 into A. Delta R is mu R minus 1 into A. If I subtract them, I will have the second formula. And how will it look like? It will look like this: mu V minus mu R multiplied by A. Do we understand this?
Yes, sir.
This is known as angular dispersion. The other thing is known as mean deviation. Have you noted it down, everyone?
Yes, sir.
Then you can just note them down in a point-wise fashion. No one is going to ask you. Mean deviation. What do you mean by mean deviation? Mean deviation means it is the deviation of yellow light. Yes or no?
Yes, sir.
Deviation of yellow. I can write this delta y, deviation of y, which is mean deviation, as mu y minus 1 times I. You don't have to write it again. If you have understood this, I'm just repeating it. And this mu y can be found out, if not given, from mu v plus mu r by 2. The second thing that you have to understand is angular dispersion. Angular dispersion. And what is angular dispersion? It is the angle between violet and R. And how do you find this angle? It will be delta V minus delta R. Formula number 1, that will be equal to mu V minus mu R times A. Do we all understand these two terms? Yes or no? No, yes.
Sir.
If you've understood these two terms, then comes the third term. Has anyone heard about the third term? The third term is dispersive power. Dispersive power. And what do you mean by this dispersive power? This dispersive power is denoted by the letter omega. This dispersive power It's a ratio. Remember, it's a ratio of, well, both are angles. It's the ratio of theta to delta m or delta y. So omega becomes equal to theta divided by delta y. Dispersive power. It is basically telling us the power of a prism to disperse colors. Do we understand this?
Yes, sir.
So I can write it as delta V minus delta R divided by delta Y. I can also write it as mu V minus mu R divided by mu yellow minus 1. A will get cancelled from both cases. So far, so good?
Yes, sir.
Anyone understands this?
Yes, sir.
Anyone having any sort of doubt? Please raise your hands.
No, sir.
Well then, the next heading is combination of prisms. Right, the next heading, combination of prism. There are two types of combinations of prism. There are two terms that we have heard. One is dispersion, the other one is deviation. So there are two types of combination. One, the first combination is known as dispersion without deviation. If this is the name of the first combination, what will this combination do? It will be a combination of two prisms. What will this combination do? Just tell me. What is this combination supposed to do? No one?
Dispersion.
It will do dispersion, it will not do deviation. Then what is the second combination going to do? Second combination,
Deviation without dispersion.
deviation without dispersion. So these are the two combinations of prisms that we will do in the next class, because we will have to spend some 5 minutes each on one combination. Then we will have to spend some more 15-20 minutes in solving questions. So there is no point of doing it or even starting it today, because I want to start it and finish it in one go. And the time for this class is also over. So this is it. In today's class, we have seen the what do you mean by dispersion. We have also seen grazing incidence, grazing emergence, normal incidence, normal emergence, and we have solved some really beautiful problems based on this. In the next class, we will be starting with your prism, I think, which is your next class is tomorrow. We finish prism and we'll move on to the last part of this chapter, which is the biggest one, refraction through spherical surfaces. So we'll begin with that. I hope to see you next class. Take care. Have a nice day. If you have any doubts, please ask.